So, welcome to the second week of Catalysis Stability 2105633. This week, we'll talk about the fundamentals of catalysis. So, let's see what we have today. So, the content, I will classify it into four parts. The first one is to describe how we classify the catalyst, and then we will learn about which components of heterogeneous catalyst there be. And then we will talk about the properties of the catalytic materials. So catalytic materials is another name of catalyst. So normally there are three main properties which are the physical, chemical, and catalytic. And for the final topic, we'll talk about the 7 steps in heterogeneous catalytic reaction. So the catalyst that we will classify, it can be classified into three types. First one is the homogeneous catalyst. Then we will have the heterogeneous catalyst. And lastly, we will have the biocatalyst, or the things that we call enzymes. So the first two is the first one is the homogeneous catalyst. As you can see, the homogeneous mean that the catalyst is in the same phase as the reactants and products. So this type of catalyst, it can be as simple as the organic acid. The inorganic acid. For example, the sulfuric acid H2SO4, like in the reaction of the esterification, in which the carboxylic acid reacts with a alcohol. So the acid catalyst, in this case, is the sulfuric acid, acts as the catalyst and catalyze the reaction, and itself it is in the same phase as the reactant and the product also. Another main type of homogeneous catalyst is the organometallic. So as its name says, that the organometallic, so we have two parts. The first one is the organo, or the organic. The second one is the metal, or the metallic. So this type of catalyst, in which I show in the slides, in this slide, this one is the Wilkinson catalyst, in which we talked about it last time, that Professor Wilkinson has invented it, and he won a Nobel Prize in chemistry. So this type of catalyst, they will have the metal center surrounded by the ligands of organic compounds. So in this case, the dark green, the olive green is the metal, while the orange atoms are the phosphorus, and the black one is carbon. So we saw the benzene ring surround the phosphorus to form one ligand, and we have three ligands surrounding the metal center, and also we have the chlorine atoms as the green atom. Next one is the heterogeneous catalyst. As its name states, that the heterogeneous means the catalyst is in different phase. Different phase of the reactant or products. But this one is highly used. They found many use of this catalyst in industry, since it has a pros of for the sake of separation. For example, the simplest heterogeneous catalyst that we can find is the nickel supported on silica. that catalyze the dry reforming reaction or the steam reforming, which react the steam with the um, methane to form the syngas of CO and hydrogen. So the first picture here is the microscopic level of the rhodium metals supported on the silica support. So as it has heterogeneous catalyst is the solid phase, is in the solid phase, while the reactant can be in gas phase or liquid phase depending on the reactions. And then on the right you will see the catalyst of a larger particles. So in real use, they will um, they will fabricate the support and or extrude it as a large one in order to pack it in the pack bed, which is the large reactor in the industry, especially the chemical industry. Then on the support, they will coat the active side, which is the metal active side, in which we will learn further in this class. The last one is the biocatalysts or the enzymes. So mainly in chemical engineering, we would not talk about this much, except the biochemical laboratory, the research center. So is the proteins. So as you know from your high school's content, that the proteins comprise of the small units, which we call the amino acid. So the sequence of these amino acids determines the properties of the enzymes. So the enzymes acts as the same as the first two types of catalyst, which is they catalyze the reaction, but it's more selective than the first two. But also the conversion is not that high, and also the degradation happens really fast. So now, as we know the types of catalysts that we have classified into three types: the homogeneous, heterogeneous, and biocatalysts. As this is the chemical engineering course, we will focus on the heterogeneous catalyst. But uh, what components that is in the heterogeneous catalyst? So the answer is in the homework that I gave you last week. That's why we have homework number 1. The first homework is to ask you to draw a picture of the catalyst and then describe what is that picture. So let's see the catalyst in your understanding. As I classify the homework, I found that there are four types of people. So the first type is the people with a simple but adequate concept. So they represent the catalyst. The first one on the top left is the particle. Is a particle that looks like a coronavirus, but still he add enough information to represent it as a catalyst. So he add the active side as the spike on the spherical model. Then on your right, you will see that there are many forms of catalyst that this guy or girl presents. So the first one looks like an extrude, and then the spherical, and then we have the cylindrical shape. So this one is also found in the industrial catalyst in the pack bed. So although simple but still adequate. Then you will see again that there are another second coronavirus style drawing, but still they have the active side and also the reactants. Next, the second type of people who are realistic and elaborative. So the first one on the most in the top left, you can see that he even include the pore of the support and also the active site that's situated on the pore. So this looks like a uh, more realistic catalyst, but as you know, we never know what the catalyst looks like because we cannot we cannot reduce the size of ourselves and go to see at the active side of the catalyst. We can only observe from uh, the secondary evidence from the instruments. So this is the model based on that. Also on the bottom right, although it's simple, he even include the uh, film. Either it can be gas film or the liquid film, and also the support and active side, and also the pore of the support. So the second type of people represent a catalyst in a realistic way. Next, the third type of people. So as you can see, now they try to represent the catalyst as a story or the mechanism of what happened on the surface. So the first one on the top, um, the person tries to represent the catalyst as a platform for the reactants to meet and form products. Also, the person explained that the catalyst reduce the energy needs for the reactant to form products. And then on the second one, on the second row, you can see that both people see the catalyst as a fit model, or like in the enzymes that we have learned that the lock and key model happens on the enzymes. So this is represent the selectivity of the catalyst to the reactant to form the products. Lastly, the final type of people is a really complex and detailed person. So on the left, the person tried to explain the catalyst as a zinc oxide nanoparticles that is surrounded by the metal atoms and also the ligand of organic compounds, heterocyclic. And on your right of the screen, you can see that this person tried to explain the catalyst in terms of the biocatalyst. And these types of catalyst consist of many units of the polypeptide or the proteins. So different color um, means different function of the proteins and different types of protein also. So as this course focuses on the heterogeneous catalyst, we will see the components that are the main element that build up the catalyst. So the three main compounds, the components, three main components of the heterogeneous catalyst is the active site, the support, and the promoter. For each of the components, we will talk in the later slides. So for the active sites, generally is a metal or a metal oxide or the metal carbide or even metal sulfide. The active site acts as a region of the reaction. So the reaction occurs on the active site. Support is the second component, which is also important in the supported catalyst. So support uh, has the duty to support things. So what things do the supports? The support is used to support the active site. So the active site is deposits on the support. So the important properties of the support is to have a high surface area to distribute or to disperse active site in high quantity, so that per gram of the catalyst that you use, you get the highest amount of active site. The last component is a promoter. The promoter sometimes is not necessary to have the promoter, but for some reaction we need to add it to control the side reactions, for example. And for all of the catalysts, the heterogeneous catalysts in the world, some have all the components, while some have only one and two. So some only have the active site supported on the support, and some only have one. So some only have the active sites. Because you can see that why do all these catalysts always have the active site and not only the support and not only promoters? Let's see to answer this, we have to see what is the duty of each of the components. So for the active site, it is a region or an area or a location where the reaction proceeds. So generally, when the reactants comes into contact with the catalyst and diffuse into the catalyst, it will react only at the active site, although some react at the interface between the active site and the support. And I would like to mention that the common active sites will comprise four main of these types. First one is the metals. So the commonly seen catalyst, the heterogeneous catalyst, is like a nickel supported on the silica, SiO2, and all the transition metals can act as a catalyst. Next is the metal oxides. The example is the vanadium oxide used as the SCR catalyst or selective catalytic reduction reactions. While the metal sulfide, as we can see, some of the example is molybdenum sulfide, which is used a lot in many reactions, which I will mention later. And the metal carbide, like the iron carbide, is also used a lot. So the active site can be used alone or dispersed on the support, depending on the reaction of your choice. But in the industry, the use of like a single active site, I mean, to use only the active site without the support, somehow will make the process too expensive, because we only need to catalyze at only to some extent. So, and also by the process in which you pack the catalyst into the pack bed or the fluidized bed, you will need a support which can bear the attrition or the crushing between the packed particles. So the support has a lot of high strength than the active site itself. So it's common to use the supported catalyst. The second component is the support. The support acts as a region to disperse the active site, as I mentioned earlier. And for this case, the high surface area is desired, and a good support should have high surface area. Also, we could see that the pore size and pore volume also varies between support to support. So the pore size, for example, can control the rate of diffusion of the reactant into the catalyst. So if the rate determining step becomes the diffusion, although you have the highly active catalyst, highly active site inside of the particles of the catalyst, you cannot exceed the rate of the diffusion. So this is an important properties also that you need to choose. Also, I would like to mention that the strength between the support and active site is also considered, and this strength has a name, and it's called metal support interaction, or MSI, which can be divided into three types: the strong, medium, and the weak. So the strong metal support interaction, which is a strong bonding between active site and support, this somehow will make the attachment of the coming reactants and the active site weaker. And vice versa, if you have a weak metal support interaction, you may have a strong reactant to active site interaction. So if it's too strong, it will poison the active site, and if it's too weak, it will dissolve just right after the absorption, and no reaction can proceed competing to that. So this is what I would like to mention, and we will learn in depth in the next class. So the last component is the promoter. The promoter can be classified into two types: the textural and the structural. So it's easy to differentiate. The textural promoter will enhance the physical properties, while the structural one will enhance the chemical and catalytic properties. So let's see the textural. So in terms of physical properties, they promote the dispersion of the active site. So in the same weight of the support, you have highly dispersed active sites in it. So this helps a lot to make the catalyst more effective. Also, it can increase the active site support stability. So this one is the same as the MSI. So increased active site support stability equals enhance the metal support interactions. So what they do is that they prevent the loss of the active site during a reaction. Next, the structural one, the structural promoter. It enhances chemical and catalytic properties. For example, they promote the formation of the defect on the catalyst. So if you compare the perfect surface with the defected one, although it's in the perception that the defect will be less active than the perfect one, in the case of catalyst, it's not. When you have a defect on the catalyst, you have a new active site because the oxidation number and the bonding surrounding that defect changes. And when it changes, all the chemical properties and including the catalytic properties change. So you have different activity. And also the structural promoter can reduce the site reactions. So by modifying the active site, you modifying all the pathways of the reaction that happens on the catalyst. So reduce site reactions. If you choose the right structural promoter, it can promote a high product of your desire. So as we saw that the components, each component in the catalyst affects its properties. Now we will see that what types of properties that we will see in the catalyst or catalytic materials. So it can be classified into three main properties: the physical, chemical, and catalytic. Although some of the books classify the mechanical properties also in the catalytic materials, but these three covers almost more than 90% of the properties. For the physical properties, these 8 properties is will cover all the physical properties that we observe in the catalyst. First is the density. So mainly it's just like a density of the typical particles that we would measure, in which I will not go into it. The important properties that I would like to explain is the pore size. So the pore size can be classified into 3 main types. The first one is the macropore, which is a pore of the catalyst for the reactants to enter. The pore, this type of pore is larger than 50 nanometers, and while the mesopore is between 2 to 50 nanometers. And also the last one, the smallest pore, is a micropore, is smaller than 2 nanometers. Next is the pore volume, is the volume in which the pore occupies within the particles. Also, the specific surface area is the total area of the catalyst particle that can be measured by the desorption techniques, in which I will not go into. Also, the 5 is also important. One important properties of the physical properties is the number of active sites, or we can call it active surface area. This is different than number 4, since this one we only count the surface area in which they have the active site, not the or the surface area. So this one will be less, the value will be less than the specific surface area. Also, number 6 is particle size, which is typical in the particle technology. And the last 2 is the strength to withstand the crush and the attrition during the process. The second properties is the chemical properties. So 4 of these properties that I would like to mention. The first one is the chemical composition. So the composition of the particles of the catalyst is mainly tells you that what element is in the catalyst or other things. This can also include the structure, the electronic structure, which is in number 3. It links together. If you choose some element, it will organize to give different electronic structure, in which it links to the number 2, which is the oxidation state. So what I would like to give an example is that if you have the same catalyst of the same element, for example, cobalt supported on alumina support, but catalyst number 1, cobalt number 1, composed mainly of cobalt 3 plus, while the another one composed mainly of the cobalt 4 plus. Although we have the cobalt catalyst the same, but the different oxidation state will give a different activity, since different number of electrons will contribute in the different chemical properties, and it turns out that different chemical properties will change the catalytic properties. The electronic structure, the simplest explanation to this property is that if you have the same element support on the same support, and although you have nickel, but nickel of different planes or facet will give you different activity. Hence, it will give you different catalytic properties. So choosing the right plane and the electronic structure will depending on the plane that you choose. So it all links together, 3 of that. The last one, although it seems far from the first 3, but let's see what it connects. The acidity and basicity. So by the 2 main definitions of the acid and base is by, first one is by Bronsted and Lowry, in which they centered around the donor and acceptor of the proton or the H+. So the acid is defined as the the component that gives the proton, and the base is in opposite. While the Lewis consider around the electrons. So if we consider the Lewis, we can see the connections to the catalyst. So the definition of the acid by Lewis is that the component that receives electrons. So if you have two components that have different different tendencies to receive electron, you will have different chemical properties, and therefore you have different catalytic properties. The last one is the catalytic properties. Four of these properties in the catalytic properties is really important. The first one is the intrinsic activity, or the real activity of the catalyst. So it can be explained through these two parameters. First one is the turnover frequency, or the change in mass of the reactant or products over time. So if you can change your reactant, consume more per time, the catalyst will be more active, so it higher activity. The second one is the specific rate. So this one also is also the change in mass of the reactant per time, but also divided by the number of the active surface, or the surface area that counts only the area which have the active sites. So this one will be more fair to compare among catalysts. Second, the activity. This is one is the rate of reaction measured per the active surface area. Number three, selectivity. Although you have catalyst which is highly active, but if it's highly active towards the undesired product, you will not have a good catalyst. So this one, parameters number three, measure how the catalyst proceed towards the desired product. So it's the rate of the desired product by the rate of the rest of the products that you observe in the reactions. Last one is really important also. If you have highly active, highly selective catalyst, but it's not stable throughout the time, for example, if you can run the reaction of only like 1 hour and your catalyst die, is no means to use that catalyst, and it will cause a lot of the cost to the regeneration and the replacement of the catalyst in the process. So it will contribute to too much of the cost of the whole process. So this one measure the drops in activity per time. Last one that I would like to mention is that how the reaction proceed within the heterogeneous catalyst. So it can be divided into 7 simple steps. If you see, if you read it, you will see that number 1 and 7, 2 and 6 is the same diffusion, but of different molecules. So let me explain from start to end. First one, when you put your catalyst in the system and you diffuse the reactant into the system, although it's in liquid phase or the gas phase, the first step is the diffusion of the reactant to the surface of the catalyst, but not inside, at the surface. So this one is called bulk diffusion. So this one, the reactant will diffuse through the external film, and when it touches the surface of the catalyst, it then goes into the pore, in which it becomes the pore diffusion step, the step number 2. And when it goes into the pore and contact with the active site in which the reaction occurs, it will start to absorb. And step 3, 4, and 5 will be on the active site. So after it absorbs, it reacts by the reaction in which we desire in number 4, step 4. And then at step 5, you get the products, and the product dissolve. And when the product dissolve, it needs to diffuse out of the pore. It becomes step 6, pore diffusion. And the last one, when it reach the top surface of the catalyst, it then have to diffuse out again through the external film. Here is the color that I would like to highlight to you to see if you can see the relation. So the important things by the end of this class that I would like to give you for the 7-step mechanism is that if the diffusion of your reactant from the outside to the catalyst is too slow, although you have the super highly active catalyst, you cannot catalyze the reaction into to your desired rate. So the solution is that to prevent the bottleneck at the diffusion. So what they did in the industry is that if it's liquid phase, they will experience a lot of problems. So they introduced the turbines to agitate the system to lower this to higher the rate of diffusion of the bulk diffusion. So if you have highly active catalyst, it can catalyze at your desired rate now. Here's the reference for further readings. If you have questions, you can post on the discussion as before. The last slide. So the homework, the second homework for this class is I would like you to classify the heterogeneous catalyst. So this week you will find a paper in Catalysis, and answer these questions, 5 of it. First one, you capture the first page of the journal names and author, and put it in the box in which the answer sheet will be in the next slide. Then you answer me what is the active site they use, what is the support they use, what is the promoter. And then you give an example, the sentence in the paper that they mention the property that they measure, 3 types of the property that I taught you today. And the last question is, and please answer what type of properties is that, and then upload it before the next class. And here's the example in which you can see and have a further discussion with your friends and upload it. Thank you. And here's the answer sheet.